Okay, so let us continue. Okay, so as I said, please star mark this ninth characteristic. Okay, let us read it again. What is written? The ratio of amplitudes of electric and magnetic field is constant at any point, and it is equal to the velocity of the EM wave. Okay, see students, the first thing is that EM waves, it is made up of both, right? Electric field and magnetic field. We have seen it in the diagram as well, or the waveform. Not a diagram, it's a waveform. All right. So here, what is the amplitude of electric field? It is denoted like this. Okay, or you can see E vector is indicating electric field, mod is indicating the modulus. I hope you all know this modulus thing. Okay, fine. So that mod is indicating amplitude. All right. So E naught mod is the amplitude of electric field, and B naught mod is the amplitude of the magnetic field. Okay. So what they are telling is that the ratio, okay, the amplitude of electric field divided by amplitude of magnetic field is nothing but equal to C. Okay, fine. It is nothing, it is a constant at any point, like in the entire EM wave, any point you all take and take the amplitude of E, amplitude of B, divide it, you all will get the answer equal to C. And C is nothing but, we have seen already in one of the previous characteristics, right? C is nothing but 1 upon under root mu naught into epsilon naught. See students, here it is the same equation only. E naught upon B naught is equal to C. What they have done is they have just simply crossed the B naught to other side, and in this equation, instead of C, they have written the formula for C. That's it. Okay, fine. I hope you all are understanding. Very simple. E naught and B naught are the amplitudes of E vector and B vector respectively. Okay, fine. Very simple to understand. Let's see the next characteristic. As the electric field vector is more prominent than the magnetic field vector. Okay, so here electric field vector has more importance than the magnetic field vector. It is responsible for optical effects due to EM waves. For this reason, electric vector is also called light vector. You all can just mark this point, like underline this, that electric vector is also known as light vector, and you all can mark this point, optical effects. See students, EM waves show optical effect. Now what optical effect is? See, I'll read out one statement. No need to write it down. Okay, it is very simple to understand. Optical effects are the result of tiny particles in the atmosphere. During its passage through atmosphere, sunlight is reflected, refracted, and scattered and everything. See, a lot of things can happen. Okay, a wave can be reflected, it can be refracted, it can be scattered, there can be interference, there can be diffraction. You all will be studying each and every term in your entire, throughout your entire physics this thing. Okay, fine. All right. Just 1 second. Let me check if it is recording. Okay, so I'll read the statement again for you all, what optical effects is. So optical effect are the result of tiny particles in the atmosphere. So in atmosphere, because of the tiny particles that are present, which are acting like obstacles. Okay, and because of these tiny particles, what is happening? The wave is either the sunlight, to be more precise. Okay, sunlight is getting reflected, refracted, and lot of other things are happening. Okay, fine. So EM waves will show this property. EM waves show optical effect, and what is responsible for this optical effect in EM wave? The electric field vector. Okay, so that is the reason it is also known as light vector. Okay, fine. I hope you all are understanding. So you all can star mark this 10th point also. Let's see the next one. The intensity of a wave is proportional to the square of its amplitude. Please mark this much part. It is very important. Okay, fine. Students, see what is meant, what do we understand by intensity? Intensity is nothing but the power transferred per unit area. Okay, intensity is power transferred in general. Okay, no need to write it down and all. Like, just if I give you all intensity, like define intensity or what is the meaning of intensity. So intensity is the amount of power that is transferred upon, like it is P upon A, power transferred through a certain area. That is nothing but intensity. Okay, now here in this scenario, intensity of any wave, okay, it is denoted by capital I. Don't get confused. This is not current. Okay. This capital I over here is intensity. Read the context. Sometimes you all will see the notations have been repeated, but it doesn't mean that it means the same. Okay. So here intensity is directly proportional to amplitude square. Like if I denote my amplitude by small a, okay, that is what the statement is. So how we can write equations for intensity of electric field and magnetic field. Okay, now see students, what was the amplitude for electric field? It was E naught, right? Capital E naught. And what was the amplitude for magnetic field? Here we have read over here. Okay, what is the amplitude for magnetic field? B naught. And what is the statement? That intensity is directly proportional to amplitude square. So what will be the intensity of electric field? Directly proportional to E naught square. What will be the intensity of magnetic field? Directly proportional to B naught square. Okay, I think so this much it is easy to understand. But we all know that as soon as we remove the proportionality sign, what comes into picture? A constant comes into picture. And here we specifically know what the constant is. Normally what we do, we write it like this, right? If we write K, we denote some variable, because we don't know what the constant is. But here we know. Okay, that is the reason they have directly given the final equations. So when you all are writing for the electric field intensity, the proportionality constant is epsilon naught by 2, or half into epsilon naught. Okay, fine. And for the magnetic field, the constant is 1 upon 2 mu naught. Okay, this I hope you all remember. Your permittivity is associated to electric field, and your permeability, that is mu, is associated to magnetic field. So that is very obvious that in the electric field one, epsilon naught will come into picture. In the magnetic field one, mu naught will come into picture. But then the placement is different. Okay, don't get confused. I mean, here in the electric field one, half is there at both the places. Here epsilon naught is multiplied and here mu naught is divided. So that is the difference. So these equations are also important. You all can just put a star mark and keep. Okay, fine. And finally, the last characteristic, okay, the energy of EM waves is distributed equally between the electric field and magnetic field. Okay, fine. So the energy transfer or whatever is happening in the EM waves, both of them equally contribute, electric field also and magnetic field also. Now you all must be wondering, in energy related statement, why they have written I, because I is intensity, right? And as I told, what is intensity in general? It is the power transferred per area. Okay, fine. So this is again students extra information. There's no need to write this down any in your answers. You all can write it down in your textbook, okay, for your understanding. So see, intensity is actually what? P upon A. Again, I suggest in bracket write down what P is. Okay, in P is power and A is nothing but area. Otherwise, you all won't understand what notation is for what. Okay, so intensity is nothing but power transferred through a certain area. Okay, fine. And power that is there. Okay, power is actually nothing but E upon T, where E stands for energy. Write it down near this 12th point only, then you all will understand. Okay, fine. Power is nothing but E by T. You all can see I is P upon T, and I is P upon A, and P is nothing but E by T. So I can say, right, your intensity is basically related to energy. Yes or no? So these formulas are just to support that statement, the last statement, the energy of EM waves is equally distributed. Then why they have written I is equal to IB? Okay, I is intensity, right? But intensity is related to energy only. So it means the same. So only to make you all understand this point, I gave you all these formulas. There's no need to use it anywhere, at least in this chapter. Okay, and do not change the equation also for intensity. Here, how they have determined the equation for intensity, these equations they have determined using this relation, that intensity of a wave is directly proportional to amplitude square. Okay, fine. Everyone, please let me know if you all have understood all the characteristics, and if you all have noted
Yes,
down
miss.
whatever I asked you.
Yes, miss.
Yes, miss. Yes, miss.
Okay,
Yes, miss.
good. Okay, what about others? What about people who are not responding? Please let me know if you all have understood, if you all have noted down. Okay, fine. Okay. Now see students, what we'll do is, next, there are a set of numericals that are given over here. Now see, the thing is that the solution is right in front of us, so I'm just going to discuss it. But you all have to practice these numericals using log and everything, okay? Because in exam, obviously, you all have to do log calculations, and here they have directly written the final answer. which will not do in exam. You all have to show the calculations also. So in, and even for your test, okay, like if there's a test of this chapter, uh, you all, and if I give any question from here, the solved numericals, then you all have to write everything properly. Okay, you all cannot just simply write it how they have written in the textbook in shortcut manner. You all have to show all the calculations and all. So I'll discuss the numericals, but it is now up to you all that you all have to practice. If this was in a class, then I would have actually made you all solve everything, but now it is not possible. Okay, so let us just quickly discuss what the numericals are. Very simple numericals. Okay, fine. Whatever characteristics we read just now, it is based on that only. Okay, fine. Let's see the first question. Calculate the velocity of EM waves in vacuum. Okay, what is the velocity of EM students? In fact, for this particular question, you all directly know the answer. Okay, the velocity of EM waves in vacuum was c, right? 3 into 10 raised to 8, which is nothing but velocity of light. But here they have told you all calculate. So you all have to show the calculation, right? You all simply cannot write the final answer. So how are we supposed to calculate? C is nothing but 1 upon under root mu naught into epsilon naught. Again, you all have to remember what mu naught is. You all have to remember what epsilon naught is. Do not expect that they'll give it to you in the question. Okay, sometimes they give, but sometimes they don't. Then what will you all do? Okay, fine. Now you all will tell me it is behind the logbook and all, but I hope you all know that in exam they give you a different logbook. Okay, not the ones that you carry or you all use. Okay, fine. They give you the one without the constant values and everything. So you all have to memorize the values. Okay, fine. And simply do the calculations. That's it. You all will get the final answer. Okay, everyone, please let me know. You all know, right, how to do log calculations. It
Yes,
has
miss.
been taught to you all, right? Yes, students.
Yes, miss.
Okay, what about others? बाकी लोगों को नहीं सिखाया क्या?
Yes, miss.
Okay, fine. Now I am assuming that you all know. Okay, fine. Let's see the next sum. Okay. Now let us see what the next sum is. In free space, an EM wave of frequency 28 megahertz travels along the x direction. The amplitude of the electric field is E is equal to 9.6 volt per meter. Okay, fine. And its direction is along the y-axis. What is the amplitude and direction of the magnetic field? Okay, see students, finding, they have given us, what they have given us in data, they have given us the amplitude of electric field, and they have asked us to find the amplitude of the magnetic field. So we know a relation between them, right? We have seen in characteristics. What is the relation? The relation is that their ratio is equal to C. Yes or no? If I just take you back to that characteristic, yeah, see over here. Okay, the ratio of amplitude of electric field to magnetic field is nothing but equal to C. So now here in my question, okay, in my question, I have electric field and C, obviously it is a constant value, and I'm supposed to find this. So I can modify this equation, right? Keep B on one side. Okay, keep B on one side. So on the right hand side, I'll have E upon C. Yes or no? Very simple numerical. So all I have to do is take my E value. Please do not forget to put the mod sign, okay? Because it will indicate amplitude, the value. Okay, fine. All right. So E upon C will give me the answer. Again, students, please do not mess up the units. Okay, again, I'm repeating C. Your B that is there, magnetic field. Okay, B is nothing. This is the formula for B. Okay, phi upon A. To be more precise, you all can write phi m. So phi m is magnetic flux and A is area. So what is the unit of B? Let me just, you all can note this down. Okay, again, this is only extra information for you all to remember the units. Okay, because some students, they remember the units based on formula, and that is, I think so, the best way. Because directly you all will memorize a lot of units and then you all will get confused which unit is for what. So magnetic field is given by phi m upon A, that is magnetic flux density upon area. Magnetic flux density is given by Weber. Okay, the unit for magnetic flux density is Weber, and area we all know is what? Meter square. I hope it is visible. So the unit of magnetic field is what, students? Weber per meter square. Okay, the unit of magnetic field is Weber per meter square. Weber per meter square is also written as Tesla. Okay. So you all can see here in the answer in front of B what they have written, capital T. This capital T is nothing but Tesla unit of magnetic field. Okay. You all have to note this down. Okay. Somewhere in your textbook, write the formula for B. Write what the unit is. It is Weber per meter square, and Weber per meter square is actually nothing but Tesla. Okay. Fine. If you all have noted down, then please let me know. Yes, students, have you all noted this down?
Yes, miss.
Yes, miss.
Okay, what about others? I hope everyone is writing whatever I'm asking you all to write. Okay, fine. Now let me just show you all quickly for the electric field. Okay, fine. So actually electric field, now this formula is in vector quantity, but now I have to just explain for units. So I'll simply write down E is nothing but F upon Q, where F stands for force and Q stands for the charge. Okay, fine. So electric field is nothing but this is actually E vector is equal to F vector upon Q. Okay, fine. All right, fine. So this is the formula. Actually, here the formula is not needed that much. So the unit that we obtain over here is volt per meter. It is written over here. Okay, fine. So I can simply write down E, the formula for E, and the unit that is volt per meter. Okay, fine. Now let's get back to our numerical. Just 1 minute. Okay, let's get back to our numerical. Okay, so students, I hope you all understood how this B has come into picture. Very simple. Use the relation. Just solve this and get the answer. But that is not our only question. Read the question carefully. See, let me just read the question again from the beginning. EM wave of frequency travels along X direction. So my EM wave is propagating on which axis? X axis. Okay. The amplitude of the electric field E and its direction is along Y axis. So if my wave is going on X axis, if my electric field is on Y axis, then what is going to be the axis of B magnetic field? Can anyone answer? See, wave is propagating, the EM wave is propagating along X axis. Okay. And we all know that the EM wave is made up of electric field and magnetic field, which are perpendicular to the propagating axis. Okay. So what are the two axes that are propagating, that are perpendicular? I'm so sorry. EM wave is propagating on X axis. The electric field and magnetic field are perpendicular to the propagating axis. In this scenario, EM wave is going on X axis. मतलब उससे perpendicular और दो कौन है? Y और Z है. Now we have to see which is where. They have mentioned that E is along Y axis. So where is B going to be? On which axis? Yes, Nandini, correct. It is going to be on Z axis. Yes or no, students? तीन ही तो axis है, दो occupied है उसमें से. Wave is going on X axis and electric field is on Y axis. Which is the left axis? The Z, right? The Z axis. It is written over here. See, in the it is given that E is along Y direction and wave propagates along X axis. So the magnetic induction B should be in a direction that is perpendicular to both X and Y. Now this how you all are supposed to do. You all cannot simply write statement. You all have to use this vector relation and you all have to show. You all have to prove कि हाँ भाई वो हमारा Z axis पे है B. Okay. So you all can see as per the property EM waves E cross B should be along the direction of propagation which is along the X axis. Okay, fine, all right. So here E cross B. So basically what we have done is E cross B, as I think so, I explained it here as well. Let me just quickly go to that property. Is that property? Yeah, it was over here. Okay, so in my diagram, see in the original this thing, the wave is propagating on Z axis, E is on X axis, Y is on B, magnetic field is on Y axis. Okay, so E cross B matlab I cross J, right? And I cross J cross product is nothing but K. Yes or no? I explained you all this thing. So the same thing you all have to apply now here in the numerical, but now the axis have changed. Okay. orally you all came to know that B is on Z axis. Okay, so but you all have to prove that now. So we will do E cross B. E is on which axis? Y. So we will write J cap. B is on which axis? Z. So we'll write K cap. And we know that J cross K's answer is I vector, and I is nothing but X axis. So this is kind of proving that whatever answer I have written is correct. Okay, fine. So and the final answer would be that the amplitude of B is this much and the direction is along Z axis. See students, orally you all can simply write Z axis, but then you all have to prove, you all have to show that okay, actually the answer is Z. So you all will use the relation E cross B. Whatever axis E is there, whatever axis B is there, their answer, their cross product should be the answer on which the wave is propagating, the axis on which the wave is propagating. Everyone please let me know if you all understood the second numerical. Everyone has to answer. You all understood the second numerical?
Yes, miss.
Yes, miss.
Yes,
Yes,
miss.
miss.
Yes, miss.
Yes, miss.
Okay, fine. Good. Okay, let us quickly see the third one. A beam of red light has an amplitude 2.5 times the amplitude of a second beam of same color. So I have two beams of red lights, okay, with me. One of them has suppose amplitude A. So the other one that is there, its amplitude is 2.5 times the first one. So your A1 is A and A2 is 2.5 A. I hope you all are understanding. Okay. For the first wave, let us consider A1. So we don't know the value, right? So we'll simply write A. But for the second wave, the amplitude is what? It is 2.5 times A. Okay, fine. Calculate the ratio of intensities of the two waves. Students, this numerical very simple. They can ask this in MCQ as well. We know that intensity is directly proportional to amplitude square, right? So I can obtain a ratio using this. Okay, I hope you all know, like when you all have proportionality, you all can obtain ratios. So here, what will be the ratio that I get? I'll get I1 upon I2. Okay, I1 upon I2 is equal to A1 square upon A2 square. Yes or no? If it is inversely proportional, then the value becomes ulta. I hope you all know how to do this. Okay, fine. All right. It is like, see, you all remove the proportionality sign. So there's a constant that comes into picture, and you all divide the equation, so the constant gets cancelled out. It is like that. Okay, that is how you get this final equation. So your I is directly proportional to A square. So what is the ratio equation that I'll get? I1 upon I2 is equal to A1 square upon A2 square. What is A1 in this scenario? It is A. And what is A2? It is 2.5A. So I'll substitute the values. Obviously, A square will get cancelled, and I'll get this final answer. Okay, fine. That's it. That's it. Till here, the sum is there. This is next theory part. Okay, fine. Everyone, please let me know if you all understood this. You all know, right, how to obtain these ratio equations and all. If it is directly proportional, then the value will be in front of it only. Okay, like for example, if let me consider something that A is inversely proportional to B. Okay, just a random example. So iska ratio equation kaise aayega? A1 upon A2 is equal to B2 upon B1, because inverse relation, right? Yes or no? But if A is directly proportional to B, then I will have A1 upon A2 is equal to B1 upon B2. And here I is directly proportional to A square. So I1 upon I2 is equal to A1 square upon A2 square. Instead of A1, okay, I will put A, and instead of this thing, I'll put 2.5 into A. Okay, fine. Everyone, please let me know if you all understood.
Yes,
What
miss.
about others?
Yes, miss.
Okay.
Yes,
Now,
miss.
see students here, please pay attention. Actually, I made a mistake over here. See here, read the question carefully. Whatever I explained is correct. A beam of red light has an amplitude 2.5 times the amplitude of the second beam of color. You are understanding? I explained it ulta. The relation is given for the first amplitude. See, there is A1, okay, and then there is A2. All right, fine. So, what they have written, see, a beam of red light has an amplitude that is 2.5 times the amplitude of the second beam of the same color. So, actually, A1 is 2.5 times A. Okay, so A is the amplitude of the second beam. You all are understanding? See, that is the reason A1 के जगह 2.5 आया और A2 के जगह पे A आया खाली. I explained like in inverse manner. I told that A2 ka amplitude is 2.5 times, but no, read the question carefully. Okay, a beam of red light has an amplitude that is 2.5 times the amplitude of the second. So they have given the relation for the first one. जो first वाले का amplitude है वो 2.5 times the second वाला है. Okay, तो second वाले का क्या हो जाएगा? The original value, that is A. Okay, everyone, please let me know you all understood, right? What I explained just now. What was the error that I did, and what is the rectification? Read the, that's why keep a habit of reading the questions carefully, okay? Otherwise, like this blunder you all will make. Okay, fine. Alright, if you all understood, then well and good. Now next, see students, here one theory topic is given. Okay, now see, as I said at the beginning, I told you all, right, there is a chapter 8 called sound chapter. So that sound chapter is entirely based on waves, and you all will see all these equations and everything. So this is a topic that has been like kind of derived from that particular chapter. So here we won't go into that depth. Okay, all I'll tell you all what you all have to remember. I'll tell you all. See, let us read what is written. In an EM wave, the magnetic field and electric field both vary sinusoidally with x. Okay, with x it will depend actually. The axis might be different. Okay, but here they have explained with respect to which axis? X axis. Okay, fine. For a wave traveling along x axis, having E vector along y axis and B. So basically मेरा wave जा रहा है x axis में. Okay, fine. My electric field is along y axis and my magnetic field is along z axis. Okay, fine. With reference to chapter 8, we can write EY and BZ. I hope you all understood why EY and BZ. Because electric field is along y axis and magnetic field is along z axis. Okay, that is why EY and BZ. So here they have written the equations of EY and BZ. Okay, see, these equations actually it has been explained in chapter 8 how to derive these equations. Here they have directly written the equations. So all you all have to do is just remember these two equations. If you all see carefully, the equations are like same only. One is for electric field, one is for magnetic field. Okay, fine. E naught, what is E naught? B naught, we already know. E naught is amplitude of electric field, B naught is amplitude of magnetic field. Sine kx minus omega t. Now it is written over here. See students, E naught is the amplitude of electric field, EY. Okay, I hope you all understood why the subscript Y and Z has come into picture. It is indicating the axis. Okay, so E naught is the amplitude of electric field EY and B naught is the amplitude of the magnetic induction or magnetic field BZ. What is K over here? K is a constant, but it has a value. Okay, this part is important. All this is actually present in that chapter. Here they have just taken that topic directly and modified it according to EM waves. Okay, so K is nothing but known as propagation constant. Okay, whose value is 2 pi upon lambda. Okay, fine. Okay, fine. So see students, what is propagation constant? Why propagation constant is necessary? See, if propagation constant is 0, means the wave is not propagating, the wave is not moving ahead. Okay, as simple as that. Okay, propagation constant naam mein hi likha hai, propagation. So if it is 0, means the wave is not moving at all, the wave is not propagating. So it always has to be some value. Okay, and it can be determined using 2 pi upon lambda. Now obviously lambda is going to be different, right? Every time lambda is not going to be a constant. And how to, and see, lambda is the wavelength. Students, I hope you all know how to relate lambda with frequency. You all can note this down over here. Lambda is nothing but C by F. Why I'm asking you all to write this down? Maybe in some numerical you all have to use this relation. Okay, see, sometimes what they do is they do not directly give the wavelength, they'll give the frequency. Okay, and then you all will sit and wonder abhi wavelength to diya nahi hai, to solve kaise kare? Nahi, frequency diya hai na. So wavelength is nothing but C by F, and C is nothing but 3 into 10 raised to 8, right? So you all can find wavelength always. So note this down and keep. Okay, near these equations only, write this down and keep. Okay, fine. So let us read what is written ahead. So lambda is the wavelength. What is omega? Omega is nothing but the angular frequency of oscillations. Okay, omega is angular frequency All right, fine. It is omega is usually written as 2 pi f, okay, where f stands for frequency. Now students, here see what they have done is they have denoted frequency as mu or nu, I think so the pronunciation is of this particular unit. Okay, so normally we pronounce it as mu. Okay, don't get confused, it is not this mu. All right. So so I suggest stick to the notation that is given in your textbook only, don't write something else. So omega is 2 pi mu, where mu being the frequency, it is written over here, so you can underline this, or you can simply write 2 pi f also, because f is little bit easy to understand as frequency, right? Yes or no? All right, fine. So these two equations you all are supposed to remember, and what every term on this equation means. X stands for the x-axis and t stands for the time. Okay, fine. All right. Both electric and magnetic fields attain their maximum and minimum values at the same time and at the same point in space. Okay, fine. Because they go hand in hand, right? Electric field and magnetic field, you all have seen. They are always in phase. They are propagating together. It's not like एक आगे है एक पीछे है, नहीं. साथ में ही हो रहा है propagation. Okay, fine. That is, E vector and B vector oscillate in phase and with the same frequency. So you all can mark this last point. Okay, they oscillate in the same frequency and same phase. Okay, fine. So this is one theory topic that you all have to remember. Okay.